Good morning. So we have discussed that if boiler feed water contains impurities, it causes scales and sludges, causes priming and foaming, and also causes boiler corrosion. In our previous discussion, we have discussed why scale is formed, why sludge is formed, what are the causes of formation of scales and sludges, what are disadvantages, and how to prevent the scale and sludge formation. Now, let us discuss boiler corrosion. Decay or disintegration of boiler materials due to chemical or electrochemical reactions is known as boiler corrosion. Boilers, as you all know, or as we all know, it is made up of iron. And the main purpose of boiler is to give steam or pure water as per industrial standards, and that industrial standards differs from industry to industry. This corrosion, boiler corrosion, gets initiated initially inside the boiler as shown in the second figure, and it gets, by the time it gets seen outside externally as shown in the first figure, 90% of the boiler would have been corroded. Even though we have taken so many precautionary measures externally, but internally due to some chemical reactions, boiler corrosion occurs. So what are those internal chemical reactions due to which boiler corrosion occurs? Let us discuss. Boiler corrosion mainly occurs due to presence of dissolved oxygen, or it may occur due to presence of dissolved carbon dioxide and magnesium chloride, or due to dissolved oxygen, as I told you earlier. Or due to dissolved oxygen. So let us discuss these three cases one by one. The first thing is due to presence of dissolved oxygen. As we all know, natural water contains 8 to 9 ppm of dissolved oxygen. Why dissolved oxygen? So atmospheric oxygen is very important for us to respire. As it is important for us, even dissolved oxygen is very important for aquatic life. If dissolved oxygen level comes below that, then aquatic life will be in danger. So which the water, natural water, which contains the dissolved oxygen 8 to 9 ppm, which when fed into boiler under high pressure and temperature, it liberates free oxygen. This free oxygen attacks the boiler as shown. So the free oxygen attacks the iron in presence of water. Water, as usual, we know, to give ferrous hydroxide. So ferrous hydroxide once again combines with oxygen to give rust. So how this oxygen is formed? So dissolved oxygen under high temperature. What is the temperature? 50 degrees to 450 degrees Celsius. At that temperature under high pressure, the dissolved oxygen will form molecular oxygen. So this molecular oxygen will attack the iron, that is the walls of the container, to give ferrous hydroxide. Ferrous hydroxide will be further oxidized to give the rust. That is how the internal corrosion will get initiated if dissolved oxygen is present. So next, if carbon dioxide, if water contains dissolved carbon dioxide, so this is very less. So if the water contains dissolved carbon dioxide, so at a high temperature and pressure, it leads to formation of carbonic acid. So this carbonic acid is an acid, so it is weaker acid, but still it corrodes the inner parts of the boiler. So next, boiler corrosion may occur due to presence of magnesium chloride. If the boiling water contains magnesium chloride, then pH value increases to 8.5. So 8.5 means obviously the water is basic. So under these conditions, that is magnesium chloride under high temperature and pressure and under alkaline condition, magnesium chloride gets converted to give you magnesium hydroxide and HCl. There is no HCl, but only because of magnesium chloride, high temperature and pressure, magnesium chloride liberates HCl. HCl is generated. HCl, as we know, it's a strong acid. This will in turn attack the iron, that is boiler. So when this attacks iron, it will get ferrous chloride and hydrogen. So hydrogen, we are least bothered. But this ferrous chloride is highly unstable. So this, in presence of water, gives ferrous hydroxide. Once ferrous hydroxide is formed, so in presence of dissolved oxygen, what will happen? Ferrous hydroxide will get rust. That is the second part. But here, in last reaction, HCl is regenerated. So once again, this HCl will go and attack the iron. Again, these reactions are continuous. More and more iron will be corroded. More and more iron will get converted to ferrous hydroxide. From ferrous hydroxide will get formed to rust, Fe2O3. So therefore, care should be taken that to see that boiler feed water does not contain any magnesium chloride. This magnesium chloride is the main cause for scale and sludge formation. Other thing is, this is the major cause for boiler corrosion too. Therefore, utmost care should be taken that the boiler feed water is free from magnesium chloride. Thank you.